Hi everyone, good to have you here. So my name is Junhao. I'm a senior manager at Dedale. I cover topics related to industrial software, supply chain software, etc. And today with me, with great pleasure, we have the co-founder and CTO of Cognite here. Maybe before we start the interview, it would be great to hear a quick intro from you as well, Geir.
Yeah. So my background is in applied mathematics. I've always had programming as a hobby on the side since I was a kid. I worked at Google. That was my first job after university, doing machine learning there from 2007 to 2010. It was before AI became so widely popular, but it was a great experience to kind of learn the foundation of AI. Then I did a startup called Snapsale, which was a classifieds app, so for buying and selling used stuff, which also used machine learning. So it would have image recognition. You would take a picture of what you want to sell, and it's automatically classified and so on. Sold that. Wasn't a big success, but I learned a lot through that journey after 6 years, and then was part of the founding team at Cognite in 2016. And since then, been working in the industrial space with industrial data operations and AI.
Super interesting. Great to have you here, Geir. Maybe starting with the interview questions. So first one is, because I think a lot of investors know broadly about the industrial software space, but it would be great to let them hear a bit more like about Cognite, what you do, what's your vision about the business, what you try to achieve that others cannot.
Yeah. So I came from the outside into industrial software with this really naive belief that we would apply machine learning to industrial data and create a lot of value. So the vision was really, and still is, to use data and AI to free up human creativity in the industrial world and use that to make industry safer, more sustainable, and more efficient. And then we had this unfair advantage in the beginning where we had a customer. So we had access to real industrial data, real experts, real facilities. And we just saw that the data space was incredibly fragmented and siloed. And so we realized very early on that the real problem that needed to be solved before we could reach that vision was kind of extracting all that data from the hundreds of legacy source systems and making sense of the data. So structuring it in such a way that it becomes meaningful to humans and machines. And so that's what Cognite Data Fusion does. That's that data foundation. That's lots of connectors to various industrial systems. And then it contextualizes the data, puts it kind of into a consistent data model, and makes it available for applications, for AI, for analysts, etc.
Super interesting. And in this context, like, would you say the biggest challenge for customers are about like handling or managing fragmented data? Maybe to go a bit into more details, is about like data on different, let's say, infrastructure, because largely they have, let's say, on-premise setup, but also some has more hybrid.
Yeah.
Also, they have the issues about like fragmented tech stack, or maybe potentially cyber issues.
Yeah.
Making the whole use case much more complex. If you can elaborate a little bit, like from your experience, what do you see as the kind of key challenges for customers in this space, and how can Cognite solving these key challenges?
Yeah, so I think with AI now being much more powerful than it was, so everyone's focused on kind of how do you create real value from AI. And I think there are two fundamental problems that's really hurting you here. One is, even though AI changed a lot, it didn't change in the sense that it is still probabilistic in nature, and the tolerance for error in the industry is very low. And the second problem is about scale, right? If you need to spend a lot of time kind of optimizing or creating the right guardrails and or connecting to the right data sources for each piece of equipment, then yeah, you may solve it for one pump, but what about the thousands across your entire fleet? And so we've always seen this kind of proof of concepts, but it's been very hard to scale. And I think that is the biggest issue. And also the motivation for us to creating kind of this data foundation where the data looks the same no matter what system it came from. And that's sort of the idea behind Cognite Data Fusion and why we actually need to copy the data out of the source systems, structure it and optimize it for consumption.
And would you say, like, if we try to maybe structure it a little bit, like, what are the kind of key characteristics of industrial space or industrial customers that kind of deploying AI at scale that could make them, like the story or like the use case, very different from if you think about like marketing tech or other spaces that looks more horizontal?
So the industrial business is largely physical, right? Their operations are physical. So when I was doing machine learning at Google, their business is digital, which is a great advantage when you're doing this kind of thing, because my team was building a machine learning model that estimates the probability that you click on an ad and then convert, so you buy whatever the advertiser wants to sell you. That data sits in the search logs, the click logs, and the conversion logs. Same format, same place. They're correlated, so there's an ID in the conversion log pointing back to the click log, pointing back to the search log. So it's very easy to correlate across the three and kind of build your model and do the machine learning at scale. And if it's a user in Japan or it's a user in Germany or in the US, it's the same format, right? Whereas if you go to industry, you have these very old legacy sites built 50 years ago. The systems are, nobody wants to touch them basically because that could get very expensive. And so you have to deal with all this entropy of different sites, different systems, and a lot of the operations aren't even kind of digital, right? So you have an incomplete picture of the totality, and then you want to apply AI to make it better and solve these processes. So it's much easier to kind of use AI to optimize marketing or a process that is also already largely digital versus a process that is physical and may not be monitored in high fidelity. So I think that's the sort of fundamental issue that industry faces. And sure, newer plants, like if you build a new plant now, and we're part of some of those projects, they are super well instrumented. They have great digital twins. We have the CAD files and they are in sync with reality. You can automate a lot of things, but these things live for 50 years. So a lot of industry is going to be brownfield and require a lot of work on the data side. And that's what we built is sort of connectors to these old systems and tools and orchestration to kind of onboard the data and the quality that sits in the source system into something that is consistent across that fleet.
And if you think about like in the context of deploying AI, I guess the first step for many customers is to have the digital twin or have the data contextualized, right? But if we think about further steps, like moving forward, like when customers deploy AI, where are the kind of, let's say, key use cases that you see more frequently happening in the space?
So I think when you're selecting use cases, you have to sort of take into account the nature of AI, right? It's always going to be probabilistic. You won't always get the right answer. Maybe 9 out of 10 times you get the right answers. You have to pick use cases where getting the wrong answer occasionally is not catastrophic. So that's number one, right? You can't use it for safety critical, and EU AI Act is actually quite sensible in this regard. We see a lot of customers kind of speeding up processes that used to take a long time for engineers when it comes to kind of data retrieval, investigation. There's this process called root cause analysis, where an engineer, like something goes wrong, an engineer will have to go in and kind of troubleshoot what went wrong, and it could take a long time to the root cause. And we speed up that tremendously from months to half a day using agents to kind of create what we call a cause map. It's kind of this tree of different hypotheses of what went wrong, and then correlating, like checking each path versus the actual data. At the end of the day, an engineer still goes in and kind of reads through this, does it make sense, and makes adjustments. But all the data gathering, creating the framework is done for you. I think a lot of these kind of maintenance operations workflows can be sped up a lot. What we hear from customers is like when they do planned turnarounds, everything runs very smoothly. They spend months kind of figuring out exactly what maintenance they should do, making sure they have all the parts, all the technicians, they're certified, they know what they're doing. When you have unplanned downtime, they can't do that level of planning. So, they try to schedule the work, but then the right part isn't there, or they don't have the right technician, or there's some kind of conflict, and then it's you got to redo it, or it takes longer. And this kind of intelligence at your fingertips that AI represents, you can do basically the same level of planning for those things in like minutes, right? Which would have taken months for humans to do. And then kind of you could reduce the unplanned maintenance by a lot by just kind of planning it out or like doing it in much more efficient ways, making sure that the supply chain logistics, all the things line up. And also, I sometimes get to go to these sites, which is fantastic. It's a lot of fun. I go into these control rooms. There's lots of alarms. I don't know if you noticed, but like they have hundreds of alarms on mute. And that scares me a bit. Like, how do they know that you can safely ignore this alarm, but not that? So there's a kind of overload in alarms. It's based on experience. Like the operator's been there for 20 years. He knows like that sensor is not that great, and we can run it safely anyway. But these guys are retiring, and the kind of normal machine learning models tend to look at a single sensor at the time to try to, is there an anomaly? Whereas the operator will look at that and, know what work orders are being performed that day in the plant, what happened last week, these other time series or other sensors that may be correlated and tell more of the story. And I think there's a huge opportunity in kind of training an industrial large model, not necessarily language model, because it will read, it will take time series as part of the inputs. It will take engineering drawings. It will take work orders and data sheets. But then looking at all the telemetry that's coming in, assessing it, and then being much more clever about what alarms you actually surface to the operator. That like, hey, this looks like it's a real thing, versus there was this maintenance being done, so actually the pressure is zero, or not zero, but so you avoid that alarm fatigue. And I think you could kind of chain these things together too. You could have one model which sort of understands that context. It sees that something seems to be an anomaly, and then it triggers sort of this root cause analysis agent. And so we can provide the operator with like a preliminary report along with it. But I think in the sort of maintenance operation space, there's huge opportunity. I haven't looked that deeply into sort of the CAD, the building stuff, designing new things. But I guess there's a lot of opportunity there as well. But you gotta kind of have these guardrails around your use case. Those are the good use cases.
So kind of, in a sense, starting with more the root cause analysis, the maintenance operations to optimize that part, which is where you have more obvious, let's say, ROI or hard dollar savings or optimization opportunities for customers. And then probably more in the future, like the design engineering part of the workflow can be further optimized with AI.
Yeah, I think there are examples of companies kind of doing these kind of generative designs, and then you evaluate it using kind of more deterministic methods, see what would happen if you try to run this plant, and then you can test out a lot more than you can do with human engineers building it. But at least for us, our stronghold is kind of in operations, and then we're gradually expanding and kind of taking in more and more data that's sort of related on the side. So you start with the factory floor, you have all the machine data, you have the work orders for the machines, but then you kind of maybe you take in MES data as well to get a more complete picture. Maybe you bring in supply chain data, and then you can do optimizations that are kind of more holistic in scope.
Super interesting. So kind of technically, how it works, kind of you have different agents taking care of different, let's say, decision-making process. You have some that is comparing time series from different sensors. You have then link it with the kind of asset mapping or asset logic connections to, let's say, identifying through the whole manufacturing process or maintenance process which are the kind of root cause with the abnormal, like kind of connecting to the abnormalities of the time series, and then also understanding who are the kind of stakeholders involved and who should be alerted for, let's say, a real alert to act on things, and what are the kind of workflows to act on a specific, let's say, field work, field service work, which is the right technician doing what with what spare parts, etc.
That's exactly what we're seeing. Is now, it used to be this was only a system of sort of intelligence and you would get advice from it. But now more and more customers want to have kind of write back to the source systems and have the operator be able to, click a button in Cognite and have an action sort of written. Like, you have an agent that looks at the problem, drafts a work order, and then you look at that and you hit submit, and then that work order is then written back into SAP or whatever the CMMS, the system is. And that is very exciting. You kind of close the loop a bit.
Super interesting. And if we think about, because a lot of our kind of clients, or let's say investors in general, are assessing a lot of AI disruption risks. So if we think about incumbents in the space, like a Dassault, Siemens, Ansys, PTC, etc., like those that does more like a CAD, CAM, PLM, or even like manufacturing systems, or even field service management software like Service Titan, like Service Max, these guys, do you feel like, how would you think about the kind of AI disruption risk to those incumbent industrial software providers? Do you think they will be more obsolete in the future, or actually you guys will coexist? Or
it's a very deep question, and it's hard to answer. Like, I think the most difficult things to disrupt is, with AI in particular, are those things that are very close to kind of this low error tolerance parts. So if you're very close to the control system, these things tend to be more sticky. You want to have a system of record that is deterministic, right? And you probably don't want a vibe-coded deterministic system either. It may have bugs that are, even though it's deterministic. I think a lot of the things that are close to the UI are very much at risk of disruption. I think the platform, the requirements on the platform are probably even stronger with all the vibe coding going on, because now platforms are hit by all of these vibe coded applications that may not use the best request patterns or may have security issues and so on. So the platform has to be super strong and hardened. And you probably see more of these sort of headless systems, because every industrial enterprise thinks they're special, and to some degree they are right. The legal regulatory requirements for an Austrian E&P or oil and gas company is very different from in Nigeria or other places. So there are legitimate differences, and so they want these user interfaces and user experiences tailored to their company. And with AI, you can make that. Like, if you have a strong platform underneath, it is very fast to build these user interfaces. And that was the thinking behind Flows, which we launched last week. You sort of, we have this strong platform. It has all the data, from across the enterprise, and it has all the security things. You can slice and dice, access control, and so on. So why don't you make it easy to build these thin user experiences on top, just using human language, and the uptake on that has been tremendous.
Super interesting. And maybe specifically two type of systems I would like to get your take that may be easier to answer from your perspective. One, I'm thinking about PLM software, because to some extent they're kind of in a very light way of explaining like a document management, but like very intelligent way with a lot of logics embedded. Thinking about like digital twin and AI that kind of serve the purpose of a PLM.
Yeah.
Do you feel PLM is a market that might in the future be less critical?
We have customers who are building essentially that on Cognite Data Fusion.
Okay.
So you can do it. So I think that is certainly something that could be disrupted. I think historians, there's an edge component to historian, which I think needs to be there. But the whole enterprise historian, I think, is very much ripe for disruption. And it should be combined with a strong time series native AI. I think that will offer a tremendous opportunity. And the cool thing about sort of these LLM-like architectures when applied to time series is they can one-shot things. So you don't need to train it on a specific equipment. So it's incredibly scalable too. So that is something that is very exciting. And I think there will be disruption there, probably coming from sort of the industries where there's a little bit less regulation at first, but then spreading when people see that it works. Well, we get this from quite a lot of customers actually, that they want to sort of bypass their historian because they have the data in the control system in OPC UA. We have an OPC UA connector. So why do you need Site Pi or even Enterprise Pi? You can just pipe it straight to Cognite Data Fusion, and then you don't kind of lose the data that Pi compresses away.
Kind of you connect directly with the machines or IoT sensors and bypassing the existing historian level.
Or we connect to an OPC server, which the more modern control systems tend to have.
True. Super interesting.
Yeah.
And another one is more in the kind of field service pairs, like think about Service Max, or even to some extent like EAM, like Enterprise Asset Management plus field service management software. Think about players like IFS or Service Max, PTC, those guys. Do you feel they are also being a bit disrupted by AI in the future?
Well, I would suspect, I don't know, I don't have good data on it, but I would suspect that it's becoming a lot easier to build such apps. And if you have a good data foundation, you should be able to, I don't see that the data or workflows they're dealing with are so complex that there's much moat. So yes, I think those are quite disruptable. I think CAD software and so on is probably less disruptable in a sense.
And why is that? Like thinking about CAD or simulation software, is it because the specific parametric rules or?
Yeah, I think they're just deeper in their understanding of kind of physics and engineering rules, and there is, if you're doing kind of calculations on things that you're building, the room for error is, tolerance for error is low again.
Yeah, true. It has to be exactly this shape with this like a minimum error, like a margin of error on the design, I guess. Actually, lastly, like MES, like manufacturing systems, do you think in the future, like platforms like Cognite or others could kind of do what they're doing nowadays, or actually you feel?
Yeah, I think so, and more probably. You make them a lot more intelligent than they are today. Not that we're doing that, but again, that's my unqualified opinion of MESs. There may be something that I'm missing there.
So kind of, if it's more about like, so if I try to summarize a bit or try to have some takeaways high level, it's like, if it's a system that is managing purely like workflows, with some tolerance of error into it, that would be easier to be disrupted in the future. But if it's deep physics, very low tolerance of error, that
I think in general, like these AI use cases, if there is a good baseline already, that's harder for you to win. And physics is a kind of a baseline like that. Like we spent hundreds of years kind of understanding these laws of the universe. And the universe seems to abide by those rules, and we have great physics simulators, and it's very hard for sort of AI to beat them in accuracy. The problem with the physics simulators is they require a lot of setup. So you've got to model reality really precisely for them to work. You've got to have all the boundary conditions and stuff. And then they can be quite computationally expensive to run as well. So we've taken sort of the hybrid approach there. We have a lot of connectors to physics simulators, especially for oil and gas and kind of process industry. And there are some very good but very expensive simulators out there. And we just connect to them and orchestrate simulations. I think AI, like if you have an AI agent, the simulator is a tool for that agent. So you get a report that something isn't flowing as it should, or maybe you want to optimize the flow rates or settings in your plant. The agent should be able to trigger a simulation with given parameters, like what happens if I open this valve 60%? Run simulation, get answer, and then the agent will sort of figure out what to do about that. Oh, it looks like 60% is a better setting than 40%, which we have now. Let's advise the operator to do that.
Super interesting. Makes a ton of sense.
Yeah.
I'm just moving forward on the question list. So if we have to think about if we have to imagine if it's possible, like in 5 years, because nowadays customer tech stack are, as you explained, like very fragmented, scattered around, no standard data, etc. How can we think about like in 5 years, how could their tech stack look like? Would it be in a more AI native world?
Again, it's a very deep question with lots of possibilities. Yeah. But I think we will have parts of the stack that are sort of deterministic, and a part of the stack that is probabilistic or AI. I mean, AI is going to stay probabilistic. Yeah. It's sort of in the nature of the thing. And with generative AI, it's even worse than in the good old days. You would get a prediction and a confidence number. Now with the generative AI, you only get a prediction, but no confidence number. Actually, you get a value associated with each token that comes out. But since the answer is a long string of tokens, it's pretty hard to kind of interpret the confidence, and the models are really good at sounding confident even though they're not. So the probabilistic thing stays, and so you need guardrails around that. You need a system of record which an auditor can trust, and you can say like this actually happened. So you won't send the sensor data straight to an AI and not store them. Like you will store them, and then you'll have the AI look at it, but you won't let the AI overwrite it. It's really hard to secure this AI stack and have good guardrails around it. So you got to be like I've been playing around with OpenClaw, right? It's amazing what it can do, and it's very tempting to give it access to all your emails and calendar and credit card and all that stuff, but then it makes a mistake 1 out of 10 times, and then it's catastrophic, right? And so you can't really give it access to all those things, because then people can send you an email and fool it to give them your credit card info. So the setup that I came up with is 2 Raspberry Pis. You have one which is sort of the sandbox for OpenClaw, and OpenClaw runs there. There's nothing secret on that Raspberry Pi. There's another Raspberry Pi, which is the only thing that Raspberry Pi is connected to.
Okay.
That's the deterministic system. It has access to my Strava account and various things. So OpenClaw can ask this thing about certain things that I have pre-configured, like it can get my latest Strava workout. So now I have this granular control. I know what I can feed it. So there's a deterministic layer and there's a non-deterministic layer where AI can do its thing. And I think there needs to be these guardrails in the future infrastructure of industry as well. What it comes out to at a grand scale is kind of hard to say, but I think there will be sort of this platform aspect where you have deterministic things and controls and really granular access control. That's super important when you're dealing with agents. You want them to have just the right access, and preferably no greater access than the person who can ask the agent, because that person can kind of fool it to do things that it wasn't supposed to. And then you can kind of certify from the guardrails around them how bad things could get. Of course, in most cases, things will be better. The use case that I started my career with was ads placement. It was a great use case because it had very limited downside. So if our model makes a mistake, we show you a poor ad. You don't click the ad, Google loses a little bit of money. But nobody gets hurt. Nobody even will notice realistically. But if the model that we built is better than what was previously there, which was sort of random, then Google makes more money, right? It's kind of statistically true. So we gotta find these use cases where you mitigate the downside risk somehow, and then you have a better than previous average, and then you make money, you run operations smoother, and so on. That was a very long answer to that question. Probably digressed far too much, but also we see these kind of vertical platforms emerging. Like the company that we meet the most kind of competitively is Palantir, right? They have a stack that's sort of similar. They have ontology. We have something that we call data modeling, which is knowledge graph for industry. And they're both made to be sort of interactive level performance backend for applications that you build to business end users. Yeah. So I think in the future, companies will have what Palantir calls ontology. We call the knowledge graph, and there may be others, building similar things. I don't know. So there will be that, and that's part of the deterministic platform, if you will, of a future business. And then there will be lots of agents. Agents will be by far the largest user group of your platform. Agents don't really need a user interface. They like APIs or MCPs or what the next thing will be. And those are going to be sort of the seats of the future. I think you have to be open to the fact that there are many different agentic frameworks or platforms out there. Some customers will have their agents in Azure Agent Studio or whatever they renamed it to now. Some will have them on AWS, some will have them in Databricks, some will have them in whatever SAP calls theirs. And you got to be open to that. And I think openness on the platform is key. The enterprise is not going to be like just one agent platform, one platform. But I do think that data has some gravity, so you will have some larger platforms. So I hope Cognite will be one of them. And then you need connectivity to the various other systems of records. Some may go away, like the historian, potentially, right? In some cases, certainly for a new plant where you already have OPC UA in the control system, why will you need an extra piece in your architecture? Doesn't make sense. Maybe other things, other systems of records like the PLM will go away, so that becomes part of the platform as well. But there will be certainly the control system is not going away. And so you need kind of these connections. Thus far, we've had one-way connections mostly, with some exceptions. Like SAP, we do sometimes write back, but you'll have more of that write back. I think eventually you will be closing the loop more in a safe way. So like, let's imagine you have an oil field and you're controlling the different valve settings across the different valves. You're working on set points. Like as long as the set point that you're writing back to the control system is safe, then it's a safe optimization that you're doing. And rather than doing that kind of optimization once per day, which a human would be able to do, maybe, you can do that, every minute. You're running the whole thing more efficiently. I think the control system of the future will be more hardened in the way that it will have an envelope where you can set kind of safe things, and then it will not allow you to go outside that envelope. Embedded in the control system itself is deterministic logic that will for sure stop the thing from blowing up.
Yeah.
Right? And if you have that limits the downside, which is what you need for AI use cases to actually work in the real world. I think that kind of architecture starts to get very exciting, because now you have a platform, it knows everything that's going on in the enterprise, both in the physical world and in finance and supply chain, all that stuff. And now you can have AI agents sort of working on top of that and optimizing the whole thing. Then it starts to get exciting. Maybe we'll get there in 5 years, maybe it's longer. Let's see.
It's a very interesting vision. And thinking about like the way as we go there, which is like hopefully a beautiful future for industrial, like we do see like some, let's say, challenges, as you mentioned before. Maybe we're starting with the point about like kind of data harmonization part, meaning like customer, they have fragmented tech stack, different data versions, etc. And we see also a lot of like AI startups in the industrial space. They struggle to, they have a great AI agent or model, but like because of poor data quality, the results are not so great. And I believe Cognite kind of solved that problem. So would like to get your take on kind of how do we manage these or try to avoid those kind of garbage in, garbage out type of problems for AI industrial platforms.
I mean, it's a hard problem. I don't think it's ever fully solved, but it is sort of the heart of what we do is sort of that data of quality, which is a lot rule-based, sometimes agentic-based, where you have different. So every customer, every data product has its own sort of definitions of what good data quality is, right? There's so many facets to that, but with AI now, we can have users kind of defining in words what they mean by good data quality and translate that into rules, which are then run continuously. And then you get sort of these reports, at least on data quality. We can fix some of it by setting up the right logic in the data onboarding. It's not a solved problem. It's semi-manual. There's lots of approvals in those flows. It's very diverse. Like, for instance, parsing an engineering drawing that's been scanned from paper is a very difficult data quality problem to ensure that the graph structure that you get out is exactly what is in the drawing. I think it's one of the hardest things that you can do. But there are lots of things that you can do that are much easier. So it's sort of, you don't get to 100%, but you get to progressively better and better scores, and you provide some visibility into how much you can trust each data set or data product.
So if I understood correctly, so it's kind of like you have, of course, there would be a service element to the, I would imagine, in the implementation phrase, but in the platform itself, it has also kind of maybe an AI agent that is doing the data processing or pre-processing.
Yeah, so the data isn't typically processed by the agent. The processing rules or logic or pipeline is set up by the agent. And then the data comes in and follows a deterministic path, just because the data volumes are so big that if you wanted to process it using LLMs, it would be very expensive. And then again, it becomes deterministic, which is a good thing. So you can kind of have the agent set up the data pipeline, and then you can have someone review, does this make sense? test run it, see what the data now looks like, get an overview of what the data quality will be, and then hit, yeah, approve, go.
Interesting. And do you feel this part would be, I don't know if it's already kind of clear in terms of answering this, but like, do you feel this data processing part would get, like the agent will get smarter and smarter, like more efficient, less errors in the future, or actually it's still like a bottleneck in the industry?
It will get better and better. It's never going to be perfect. And that is the, I think, at least that's what I think.
Mm. And then probably my last question is the second bottleneck I see a bit in the industry is scalability. And as you mentioned at the beginning, like implementing on one side of the customer, like the oil side or like a manufacturing plant, everything is working, but then when you move to plant 2, 3, 4, 5, it's a complete different setup. Like, is there a more scalable way to deploy at like industrial sites for AI platforms? Or?
Yeah, I think the approach that we have now is scalable, and it is getting faster and faster, and much due to AI as well, which is doing more and more of the. So there is a services arm in Cognite, and we have partners who do services as well. So when you onboard a site, there's a team that sets up these data pipelines, set up the different connectors to the systems there, and also validate that what they've set up has good enough data quality at the end of it. And they will typically implement a couple of useful use cases as well that give some value. We see that now with Agentic, more and more of the work that this team does is done with LLMs. And so you kind of take down the time it takes. So that is that's encouraging. And once you've set that up, you have basically something that's running and feeding data into the same data model across all the sites. So that when you build an application on top of this, you don't need to rebuild it when you go from site A to site B. It already works.
Super interesting. Yeah. So it's kind of like scalable from like a whole enterprise perspective. This is how we manage this type of AI use case for root cause analysis. Or,
yes.
And the model is trained across multiple sites at the same time.
Yeah.
Super interesting. Great. I believe that's all the questions we have. Thank you so much, Geir, for the time.